Hello everyone and welcome to this particular video, and in here we're going to continue from what we did in class involving linear relations, and specifically we're going to look at a summary on a linear equation which is represented as y equals m, which is represented as the slope multiplied by x, which is any x value you're putting into your equation plus b, and this b value represents our y-intercept where x equals to 0. So in here, what is the characteristic of each individual variable as it relates to not only looking at the graph where y is on the vertical and our x is on the horizontal, or we're given a table of value where x is on the left side of the column and y is on the right side of the column, or we're given a point where we have our x and we have its y that is actually going to put on either the graph or is actually extracted from our table of values. So looking at these, we're going to first look at what m is. Looking at m, we notice that m is actually called the rate of change, and in here the rate of change tells us that looking at the graph we need to just find the slope. So slope is actually what is determined when we are representing that as m, and in order for we to determine the slope of a particular line, which in this case is the change in y versus the change in x, what we see is that looking at the graph, we have our y and we have our x and we have our graph right here. All we need to determine, sorry the line is not straight, but you should use a ruler in this particular case, is that once we know that there is a rise versus a run, we need to divide our rise by our run, and in order to accomplish that, on the graph we actually notice that our m is equal to rise over run, and rise, if you're going up, means that yes, it's actually positive, which is in that case, or we actually are going down, which represents negative, which is in this case, or on the other side, if you're looking at our run, if you're moving from left to right, that is a positive run, which is in this way, or on the other side, if we have the other side from right to left, we actually have our negative run right there, which is represented as that over there. So that is a way to determine the magnitude by dividing your rise by your run. The next one is that if you're given a table of value and you're asked to determine the slope, all you need to do is that if you're given a table of value, which is your x and y, we have, let's say, x1, we have our x2, we have our x3 for example, and in here we have our y1, y2, y3. So what we do here is that we find our change in x, and this change in x must give us a unique value which will represent as delta x, and this delta x is also the same thing as the delta x right here. And looking at the y, we see that going from y1 to y2 and from y2 to y3, we have our change in y, which is delta y, and this change in y, which is delta y, and these two here, they are actually the same value that we get. And looking at the change in x, we see that that as well is also the same value. So if we have our change in y divided by our change in x, we can actually determine the slope as well of that particular line, which is represented as m. And finally is when we are actually given various points, and these points, all you need is 2 points. Once you have your 2 points, in this case we have our x1 and this is our y1 for that x value, and we have another point which is x2, y2. What we do here is that we just find a change in our y, which is y2 minus y1, and subtract our x1 from x2. And so once we have that, we can actually determine our m, which is represented as the slope of that particular line. So those are the 3 strategies that you should recognize over the course of this particular lessons in order for you to determine the slope of a specific line. All you need is 2 points, or all you need is 2 or more x or y values that are represented on the table format, or finally all we need are is one line on a graph, and what we need to find is a rise over run, which is actually going to be used to determine our slope. And next is that what if we're asked to find what b is. Now b comes from what we talked about on our previous lesson, which is variation, which is one variation that is direct versus variation that is partial. And what we recognize is that for we to get a partial variation, all we need to do is to recognize that on our graph, where we have our y and x as is labeled, we actually have our line that crosses the origin, which is at 0, 0 right there. And once you notice that your graph crosses the origin, it means that when x is equal to 0, our y is equal to some value which is b, and b is equal to 0. However, partial variation means that our graph, where we have our y and our x labeled on each axis right there, we have our line, it doesn't cross the origin, rather it crosses any point on the y axis. So in this case, we represent that y axis to be b. That means here that b is not equal to 0. So in this case, if x is equal to 0, our y is equal to b, and our b is not equal to 0. So in this part, to determine that, what we need to do is that we just make our x equal to 0, and we put that into this equation, and what we get is our b value, and our b value here is actually known to be called the y-intercept. So where x equals to 0, our y is equal to a value, and this y is equal to our b, which is our y-intercept. So that is about it on how to identify our slope and y-intercept, which is represented as b. And once you're able to recognize that, whatever value of x we put into this particular equation right here, we always get our y value, which is actually dependent on our slope and our y-intercept, which is represented as b. And this is actually shown as what we see on our coordinates, which is for every x we get our y, and once we have our points, which are actually shown on our table of value, we can actually determine what our graph is going to look like once we find all our values for x and all our values for y, either on the table format or on the coordinate format right here. And this will be used to determine each point that we connect with a line, and that shows you that equation here of that particular line, which is right there. So that is about it for this particular video. Please hit the comment down below, let me hear your thoughts, or send me an email regarding any questions that you may actually be facing or you may be challenged in terms of solving, and I'm going to make a video, or I'm going to get various hints on how to solve those problems. All the same, stay smart and believe in yourselves.